Hi, welcome back. Today we're going to go through a slightly more advanced version of Altair. We're going to be doing some transformations, we're going to be doing some layering, and there's a blank notebook for you to work through as we go through this lab on the video. And when we're done, there is some independent activities for you to do sort of at your own leisure. All right, let's get going. So we're going to continue our adventures with Altair today, looking at transformations and layering and visualizations. We're going to do this in 3 different parts. So a warm-up, which is going to do a little bit of a review of what we looked at last time, talk about layering, and then some transformation like filtering, aggregating, and so on. So we'll talk about that in a lot of detail. You can kind of cleanly separate this lecture, this lab, into 3 different parts. So if you get tired, you can feel free to stop. Each of the components are sort of independent, so it's okay to pause in between. Before we get going, I just want to point you at a few resources. So there are links in your lab notebook. So as you're following along and you're confused, feel free to click out and look at any of these things. A lot of the transformations that we will do in part 3 will also have analogous transformations that you can do in Pandas. So you can either do them directly in Altair or in Pandas. We have another video that we've created for you that is in the folder for next week, but you can look ahead if you like. That basically shows you the mapping. So if you know a lot about Pandas, I would encourage you to go look at that. It's not the kind of video you necessarily want to watch all the way through, but if you're stuck on a particular kind of transformation and want to understand it in a little bit more detail, we have kind of nicer visualizations that walk you through exactly what's going on internally, whether you're using Pandas or Altair. Okay, so let's get going with the warm-up. I'm going to ask you to generate a few different visualizations, and then I'll walk you through how to actually do that. I'll show you an image. Feel free to pause the video. Actually, you should pause the video after you see the image, and then try to work through the solution in your blank notebook before I give you the answer. So before we do that, I'm just going to load up a data set. So this is going to be a different data set than we saw last time. We're going to load up Altair, Pandas, Vega dataset, and then I'm going to use a movie dataset. At the end here, there's a little bit of a transformation just to make naming of columns a little bit easier to deal with. So let's do that. We'll load it up. So let's just look really fast inside, see what's in here. So movie sample 2, and this is just a couple of rows from this database. You can see the title of the movie, the US gross, worldwide gross. So this is like the data set that we used in Tableau. Okay, so on to the warm-up. Last week, just as a reminder, we looked at using the grammar of graphics by means of Altair. So we talked about the mark, the data, and the encoding. So I'm going to ask you to apply this in the construction of a few visualizations. The first one is going to be fairly straightforward. It's a bar chart, oriented along the y-axis. So basically, the bars are going along the x, and the list of genres that we care about are on the y-axis. So what I would like to do is have you plot this. Measure genre should be on the y-axis. I'm not going to talk about how to remove nulls yet. Null is fine in there. And then on the x-axis, the length of the bars, I would like for you to calculate the average of the production budget for that genre. So there's a bunch of movies in every genre. Calculate the average production budget. So feel free to pause the video here before you go on. Okay, so hopefully you got this. It should be fairly straightforward given the homework from last week, but just in case, we'll work through this. So alt chart, so Altair, make me a chart. We're going to use the movies data set. We're going to use a bar, so the mark bar, and then we'll do the encoding. So we have on the y-axis, so Altair, make me a y-axis. Put measure genre on here, and it's a nominal variable, so like this. And then on the x-axis, we're going to calculate the average production budget. Okay, warm-up exercise 2. Same basic idea. I just want 2 charts side by side. So one should have the average production budget, and the other should be the median of the production budget. So create one merged joint chart having these 2 subcharts internally. So pause here and give it a try. Okay, so hopefully you've gotten this one as well. I'm going to copy and paste something over here just to get us started, because it's essentially the visualization for the first chart that we created in the cell above. So chart 1 is going to hold the left chart that we've created. And then chart number 2, I'm just going to copy and paste this one. So chart 2 is going to be this, and I'm just going to change this to the median instead of the average. And then at the end, I want to say put chart 1 next to chart 2 like this. And voila, we have the visualization with the 2 charts side by side. All right, one more worked example. This is a little bit of a more sophisticated chart. We want a scatter plot in the middle, which is IMDb rating versus Rotten Tomatoes rating. We want to see if there's a correlation there. And then a histogram both to the left and the right, which is the top and to the right, which is the summary statistic for the IMDb rating and for the Rotten Tomato rating. What you can see from here is that the IMDb rating has kind of a nice distribution, whereas the Rotten Tomato rating is kind of all over the place, so it's more uniform, whereas the IMDb rating is more normal distribution. What's good or bad, I can't say, but this is the difference between these two, so we can see this in the visualization. So again, scatter plot in the middle with the 2 histograms on the top and to the right. Okay, so to make this work, we're going to use 3 different charts. So the first one, the one in the middle, is going to be the scatter plot. So we're going to make a new chart. Altair, make me a chart with movies. We're going to use mark point. We want it to be filled, so if you played with this a little bit, you will have realized that the dots, if you don't do this, will have, look like donuts. They'll be empty inside. We also want this to be a little bit bigger, so we're going to make the size 90 so we can see the dots more easily. And then we're going to do our encoding. So we need on the x-axis to put this, so IMDb rating, and on the y-axis, we're going to make the Rotten Tomato rating. We'll run this. Let's just plot this so we can make sure that we're getting the right thing. Okay, that looks pretty good. So great. So let's go on to the next part. The next part is generating the 2 histograms. So let's make the right side distribution. So let's call this distrib right. And we're going to make an alt chart movies. That one is a bar chart, so if you remember, if we go back, so you can see that it's a bar chart. You can also tell that there's, maybe a couple dozen bins, so I actually know that there are 20, but that's something that we're going to want to play with a little bit to get the effect that we want. All right, so we're going to make the bar chart, so mark bar, and then we're going to encode. The y-axis is going to be Alt-Y Rotten Tomatoes rating. We're going to bin, and if you remember from last time, what we had to do was create this bin object, alt bin params. And as I said, we know that there are 20 bins in here. You're going to have to play with different settings to get the look and feel that you want. I happen to know that in this case, I don't want an axis, like there was no axis being drawn, so I'm going to set axis to none. And for the X, I'm going to make an Alt X. And remember, a histogram is basically measuring the count in each bin, so we're going to want to do this count. And again, axis equals none. Let's just make sure this is looking the way we want. So we'll do this. Okay, that's pretty good. We're going to change the size a little bit later, but we want to shrink it, but looks okay. So we'll start with this. And then for the other one, we want the distribution at the top. So let's just copy this. Actually, why don't we do this right now? So we're going to do properties width equals 30. So this applies to the entire visualization, the entire scatter plot, the entire histogram, and we'll make it only 30 pixels wide. So you can see distrib right, it'll be much smaller. Okay, so that's good. So we won't have to deal with that later. Let's do the same thing for the top, distrib top. And now we're doing IMDb rating. And remember, because we want this along the x-axis, we have to swap these things. So what used to be x is now y, and what was y is now x. And we don't want the width to be 30, we want the height to be 30. Oops, what did we do wrong? Oh, capital Y. Okay, so now we can double check, distrib top. Great. Perfect. Okay, so now we have the three visualizations that we need. We have points, we have distrib right, and distrib top. So let's go to the next cell and put these things together. So to get the points and the rightmost distribution, that's straightforward, right? Like we could just do this, and we have this part. But we also want at the top of this visualization the distrib top, the IMDb rating. So we will do distrib top. And remember, the ampersand basically says we want this on top. So this says this part over here will create a joint visualization that is side by side, and this will specify that we want this at the top. And Altair knows, because of where the axes sit, how it wants to orient these things. So it will look correct when we render it. So notice the top doesn't actually stretch all the way across over to this histogram. So again, Altair is sort of doing the right thing. Okay, before we go, I just want to introduce just a tiny bit of interactivity. We have a whole lecture on this later, but this will make it easier for you to do some of your homework and to also debug things, honestly. So there are situations where you want more data, or the points are just sitting on top of each other and you really need to be able to zoom in and get access to them. So the easiest way to get this is to just, if we have our points chart, so this is the thing we've created up top, we just add this extra method called interactive. And when you do this, now the plot becomes interactive. So you can move around and see everything and, look at smaller points and whatever. So you basically have access to more detail by being able to zoom in interactively. So this is okay, but it doesn't tell us which movie's what. It doesn't help us necessarily debug some of the internal aspects of this. And so just to introduce you to one other piece of interactivity, we can do this. Points in code. There is a special kind of retinal variable, this is in quotes, called the tooltip. Okay, so there's a tooltip channel that we can put different kinds of things on. So title, for example, can be placed as a tooltip. So let's just do this. So we're taking the points, we're adding the tooltip variable on top of that. The title happens to be the variable that we're encoding using the tooltip. And if we run this, you get a visualization like this. Now, as you mouse over, you get the name of the movie. So you can zoom in and get the name of the movie that you're mousing over. If you happen to want a little bit more information, the way to do that is to create a tooltip using an array instead of just a single variable. And what I mean by that is if you do tooltip equals, so what we did before was the title, so a nominal variable title. Now what I want to do is feed in an array instead. And I want also the release date. Just so I know, there's some movies that have the same name, so let's do it this way. And then interactive. And now when you mouse over, you see two rows, one for the title and one for the release date. And that simply happened because I've asked for tooltips to be an array instead of a single variable. So this will wrap up this first warm-up exercise. You can take a break if you need to right now, and then we're going to start talking about layering. Okay, hopefully you've stretched your legs, blinked a little bit to get sleep out of your eyes, whatever it is that you needed to do. We're going to move on and talk about part 2 here, which is about layering. So how we create sophisticated visualizations by layering one on top of the other. So in terms of our plan, we're at the second step. So let's start with our imagined goal. Our imagined goal is a visualization that we've sort of seen before, but now we've added an extra visualization that's sitting on top of it. So this is like the first visualization that you created in the warm-up, except you now see this extra line chart sitting on top of it. Now, it's probably easy for you to imagine how to create these two visualizations separately, and it turns out it's quite easy to create them together. So if you can make one, you can make the other. So how does this work? We're going to make two different charts to do this. So the first chart is going to be our bar chart. So chart 1 equals alt chart movies. Oh, okay, this should be on the outside. Okay, good. All right, so this was our average production budget. The chart that we want has average production budget in the blue bar chart and the median production budget in the orange. So we need to now create chart number 2. So chart number 2 is very similar. So let's just copy and paste this. Chart 2. And we're going to use median over here. And we want a line chart instead of a bar chart. And we want it to be orange. Let's just look at this and see what it looks like. Okay, perfect, good. Okay, so layering. Layering is just chart 1 plus chart 2. And Altair will figure out that the axes are the same and how to combine these two things. And we have one visualization overlaid on the other. So you can actually do somewhat sophisticated visualizations this way. So you can construct things like box plots and other weird things that have different kinds of marks that are integrated. But before we do anything like crazy like that, I want to give you a couple of shortcuts that you'll often see in code samples for Altair. So I just want to give you examples so you'll know how this works. So we're going to copy this particular code because we're going to modify it in the next cell. So one shortcut we can do, you'll notice that chart 2 is basically just an extension of chart 1 where we've changed from a bar to a line. And the only line that we've changed in the encoding is we've moved from average to the median. So the way to override the initial chart, we can actually just say this. So we can say chart 2 is essentially chart 1, but I want you to change the mark from a bar to a line. So Altair knows that when you're doing it, you're issuing this kind of command, it will override the encoding. We don't care about major genre because we've already defined the y-axis to be major genre, and we're going to use whatever chart 1 has already defined for the y-axis. The only thing that we're overriding is the median. So, the x encoded variable, which is now median instead of average. So that's what this encode will tell Altair to do. So basically override this x with this x. But notice we don't have to code quite as much. We can rely on what we've already done for chart 1. We don't have to say alt chart movies. We can just say chart 1 and then tell Altair what we want to change, only the things that we want to change. So if we run this, we're going to get exactly the same visualization. We're going to copy and paste this again. I just want to show one other example of this. So this is another thing that you'll see often. People will create what they call a base chart. So they'll do alt chart movies. They won't even define the encoding, like the mark that they're going to use. They're just going to skip ahead. So they're going to say encode, and they're going to say then this. Okay, so this is the base chart. And if you try to render the chart, you'll get an error because it's basically not defining enough to actually render anything useful. But this will be our base. And then chart 1 is the base with the encoding or the mark set to bar, and chart 2 is going to be the base changed to a line with the x variable changed in this way. So if you have very complicated analysis that you're doing or very complicated transformations, you might do that once in sort of the base chart, and then every subsequent layer you can take that base chart and modify it just a little bit to get the effect that you want. So this will render basically the same thing that we've seen. So it turns out that layering is also great for doing things like annotation. So this is the ugly version of the chart that we're going to get at the end. We're going to clean this up a little bit, but we've added a little bit of information on top of the bar chart that we've created, specifically the number, the value. So this is in dollars, basically the length of the bar. So it's kind of hard to read down to the bottom and figure out that this is 54 million or whatever it is. So we want to add this annotation to make our lives easier. So how do we do this? We're going to layer text. So we're going to create our first chart, which is our standard bar chart. So actually, let's just copy and paste this because we've created this before. And then we're going to add a text annotation layer. So text annotation. And it's going to be basically, we're going to take chart 1 and modify it just a little bit. We're going to change from a bar chart to from a bar based in mark to a text based mark. So we're going to do it like this and then encode. Text has a specific variable, retinal variable name and encoding channel, whatever you want to call it, called text. So we need to say what we want to appear as the text, like what from the data should be pulled and rendered on top of this visualization. So we're going to do alt text, and we're going to ask for the mean production budget. So it's quantitative. And then we're going to do chart 1, text annotation. So both chart 1 and text annotation, render them together. And that is our ugly representation. Notice it actually works. Both average and mean will do the same thing. So it doesn't actually matter. If you're confused about why we're using one or the other, it doesn't matter. Let's see if we can make this a little bit cleaner. So we're going to take the text annotation object and we're going to copy it. Oops, copy it. And we're going to move to another cell and we'll make it a little bit slicker. So mark text. We want to, so you can look up the documentation for mark text. I know that I want it to be left aligned. So I'm going to say align left. I also don't really want it sitting on top of the bar. I just want it sitting a little bit to the right. So I'm going to make it dx delta x, how many pixels I want it to the side. So I'm going to set dx equals 7. The other thing that I want to do is I don't like the kind of, the numbers that it was spitting out with decimal points, to 4 digits. We just want simple cents. And we want like a $sign in front of this. And so the way we're going to do this is we're going to modify the alt text argument a little bit. Alt text can also take in additional information like formatting instructions. So there's documentation for this, but we're going to say format type equals number. There are other types of format types, but this is just to indicate that we want a number. And then we need to specify the formatting instruction. So we want $, like we want the actual $ symbol to appear, and then S, which is basically indicating that we want things rounded to the millions. So this is what we're going to do. So chart 1 stays the same, and text annotation like this, and we render it. Okay. So we have this nice rounding. We have the little $sign. So this is much more easy to read and parse. So it's not sitting on top, it's rounded, so it's much cleaner. So we're going to end our discussion on layering here. And you might want to take a break again, and we're going to move on to transformations. Okay, welcome back. This is going to be the last part of this particular lecture series for the lab. We've gone through the warm-up layering. Now I want to talk about transformation. Transformation is going to be important because often the data doesn't look the way we need it to in order to generate the right visualization. So sometimes we have too much data, not enough, data is in the wrong shape, data isn't aggregated, so on. So people give you data sets that are misshapen relative to what we need to do in order to get Altair to visualize things properly. So we're going to talk about different types of transformations that will allow you to get the data from that raw form into something that's usable in Altair. There are other options to doing this in Altair directly. So you can use pandas if you're familiar with it. You can often achieve the transformation using one or the other. As I mentioned before, we have an extra presentation that maps between these two. So if you're familiar with one, we'll show you how to do it in the other and also walk you through the transformations in a little bit more detail. So it's going to be essentially a lab lecture that was intended for next week. But if you want to get ahead, you're confused, whatever it is, feel free to take a peek and look ahead at that material. The other thing that I'll specifically say about why you would pick one or the other, if you're using pandas, you'll often be stuck running a Python server, and that might make it harder for you to deploy. We'll show you how to do that. Like there are options for deploying Python servers quite easily. So maybe not quite a Jupyter notebook environment, but there are other ways of doing this. We'll talk about Streamlit and perhaps Voila in another lecture, but there are ways of doing this, but you do need to deploy something that is running Python if you need to execute Python. The fix for that is you might use pandas to do some of your initial transformation and then save the intermediate result. So you can have kind of JSON data or CSV data that you've transformed from the original data set and you've saved out to disk. But that again is problematic if your data is dynamic. So if you're pulling new data constantly, you're going to need the Python server in order to process it. Otherwise, you're going to need to think about using Altair. I will say that while there are advantages to using Altair, it will be harder to debug. So there are situations, and you'll see as you're doing this, where you will generate visualizations and you'll get errors back when you apply transformations, and it'll be a little bit harder to figure out what's going on. But we're going to give you a solid grounding in this particular lab. Hopefully this will get you pretty far. So if you checked out the link that we shared with you in the first part of this lab, you will have found that there's about 13 different kinds of transformations that Altair offers. I'm not going to talk about all of them, just a few of the key ones that you'll use more regularly. The first one, and perhaps the most important, is the aggregate and join aggregate. These are ones that will let you combine based on some property of the data. So aggregating is essentially a kind of binning operation, but it will allow you to calculate different kinds of things on the data as you aggregate. So this will be important for going forward. So let's do this. So calculate the average production per budget. So we've seen examples of this before. Let's do this, where we've done aggregation without necessarily knowing that we've done aggregation. So we're going to make an Altair chart. It's going to do movies. We're going to use bar and code. Actually, I'm just going to copy and paste because this is the same visualization we keep drawing in this particular lab. So let's just do this and plot it out. So this was the shortcut way of doing this. We're going to copy this and I'll show you the slightly more difficult way of doing it, which will turn out to be useful for certain kinds of things. So when we are describing what we want the x variable to be, the x retinal variable, we can actually break this apart. So we're going to say the field that we want to aggregate on is the production budget. We need to say that the kind of aggregation that we want, aggregate equals mean. And we also need to specify the type of the variable, so it's quantitative. And then if we run this, we get the same visualization. Now you might be wondering why we do this. There are other options that we might want to feed into this particular argument that will let us control more subtle things. This is, in fact, a shortcut for a specific kind of transformation. So all transformations in Altair have this form of like transform underscore, in this case, transform at underscore aggregate. So what we are going to do is show you the long form of this, alt chart movies, transform aggregate. So when we have the transform aggregate, we need to specify what we want to group by. So what is it that we're aggregating? So we have this group by argument, and we're going to say it's measure genre. Now, the interesting thing about this is we can group by multiple things. So if we had another thing to group by, we could do it in here. We're only going to group by one thing, but that is one reason why you might want this extended version. So if you wanted to group by, let's say, major genre and also by which decade. So all the movies that were action movies in 1910, we want in one bucket, 1920, 1930, and so on. We could do that this way. And then we are creating a new variable called mean production budget. So Altair knows that when you have this, you want to create a new variable. So mean production budget will be its name. And what it will calculate is the mean production budget. So the way to read this is transform aggregate will group by, we'll take all the data, group it by the major genre, action, comedy, whatever it is. And then for each of those buckets, each of those bins, each of those aggregate groups, we'll calculate the mean production budget and we'll put that into this variable, the mean production budget variable. So we're going to make a bar chart as before, mark bar. And we have our standard visualization. So we've created it now in 3 different ways. This way is probably the most powerful and flexible, but we might, in most situations, really be okay with the shorthand. The one thing that I'll caution you about when you're using this form, so I'm going to copy and paste this in another cell, just so you can see what happens. We're going to create this variable called mean production budget, but we're not going to use it. So instead, we're going to do production budget like this, and we're going to run it. And now our visualization is broken. Basically, we have nothing being displayed. What has gone on internally is the data that we fed in originally has basically gone away. So the data frame, like the data table that existed that had all the movies and had all their individual production budgets, was blown away by the transform aggregate command that we've applied. So when we've applied transform aggregate, it's basically replaced the data set with a subset, a different view of the data that no longer has these variables. So when we don't use this variable, we're simply unable to produce the right visualization anymore. So to better understand this, we might look at a mini example. So let's say we have 3 movies in our data set, movie A, B, and C. The first 2 movies are of genre X, and they have these production values. So when we apply the transform aggregate, that command that I just applied, what we end up with is a different data set that looks like this. So all we end up with is measure genre and mean production budget, so X and Y, 1.5 and 10. But if we tried to plot, as we did before, the data that requires production budget, that column no longer exists. Okay, but what happens if we actually wanted to preserve that? We wanted to take this mean production budget column and append it, basically add it to our original data set. So we wanted to create a new column in that data set that had this information for every genre, for every movie. So the way we can do that is applying a method called transform join aggregate. And what that will do is create two different data sets simultaneously, the original one and the one that we had in transform aggregate. And then it will merge those two things together. So it will look at the columns that they have in common. These happen to have major genre in columns. So title A had major genre X, and this new data set that we created, so if we go back, this new data set that we created had X as this column and the value of 1.5. So what this join aggregate command will do is merge those two data sets together and plot something like this. If you've done this in SQL before, this should be quite familiar to you, but not everyone has. So this is the output of the join aggregate command. So the same visualization that broke for us before, if we use join aggregate, will actually work now because we've preserved the columns that we care about. But again, we're ignoring mean production budget, so this might not be the best strategy. But you can see the production budget is still retained in this data set because we've used transform join aggregate instead of transform aggregate. Okay, next up is the bin transformation. This is something that you've actually done in a shortcut way before, just like we did with aggregation, and I'll show you the long form of this in a second. So before we do that, try to replicate this visualization. So this is a fairly straightforward one. I'll pause here, or you should pause here, and give this a try, and then I'll work through the example. Okay, so the visualization was essentially a binned IMDb rating with the mean production budget plotted as sort of the height of the bars. So the visualization, probably the way you created it, is something like this. So alt movies, mark bar, code. We, on the x-axis, we're putting the IMDb rating, which is quantitative, and we specify that we want these to be bin, so bin equals true. And then alt y should have the mean production budget. Oops. Got a parenthesis. All right, so this was the visualization. So this basically said bin by IMDb rating, so create different bins. This one is IMDb rating between 1 and 2, between 2 and 3, and so on. And this is the visualization. So this is a shortcut, and it's perfectly fine. In a lot of situations, you're going to be happy with this. There is, just like we saw for aggregating, a specific transformation called transform bin. So let's do it this way. So we're going to do, so transform bin takes a few different arguments. The first one is the name of the new variable that you want. So we're going to call this the binned IMDb rating. And then you need to specify what you would like to be binning. So IMDb rating. There are other arguments here, like the width of the bins and all this stuff that can be fed. So this will give you some fine control over the way binning happens. By the way, I should mention that hopefully it's obvious by now, but what Altair is going to do is whenever there's a transform something, it's going to execute that transformation before it tries to encode. So it doesn't actually matter the order that you put these things in. You can actually put encode up above or afterwards. It's just easier to read this way because what we're saying is, Altair, do something, create a bar chart, transform this data in this way, and then encode it. So it's easier to read when we sort of construct all the transformations in advance, but we can stack them, and we'll see this in a second, essentially creating multiple transformations and then running the encode afterwards. So encode is what we've used so far, Alt-X. All right, and that's it. So notice the bins are a little bit different in terms of look and feel and style. So there are some defaults that are a little bit different when you use transform bin. For good or ill, this is just the way it's set up, and you can override these things. So you can make like the bars a little bit wider or make them look the way you want. So what happens if we're missing data? You can remember that when we did the Tableau exercise, we needed to calculate this extra column called revenue, and we can do the exact same thing using Altair. So how do we do this? We use transform calculate. So let's make a chart. So Alt chart movies. We're going to create a new column. We're going to call it revenue. So the thing that we will calculate will go into this column called revenue. And then we need to say, how do you calculate this? Like, what are the instructions to give to Altair that will describe the way this is done? So altdatum is a way of describing the current row. Basically, what Altair will do is go through every row in the data set, and as it goes through them, it will put the value for that row into this variable altdatum. So we can say altdatum worldwide gross. So that's the current column that we're looking at. Subtract the production budget for that row from the worldwide gross for that row. Okay, so now we have an extra column called revenue, which has the subtraction of production budget from gross. And now we can plot this. So mark point.encode. Okay, so now we're going to use this extra revenue variable that we've created and get a visualization that looks like this. So we have our nice scatter plot with measure genre down at the bottom and the revenue plotted along the y-axis with dots representing every movie in our data set. So this is one way of doing this. Here's another. So I'm just giving you this example because you'll sometimes see the examples out in the web look like this. So instead of alt.datum, you will see it like this. So this is a slightly different form that Altair also understands, or actually I should say Vega Lite understands. So when you use the form before alt.datum, it will actually internally transform into this. And this is it happens to be a JavaScript representation of the data set. So both these things will work. You can basically feed a string in that has your formula, but then you don't need the alt part. So it's just datum.worldwide gross minus datum.production budget. And if you run this, you'll see that you get exactly the same visualization. So in all the charts that we've done so far, we've largely created a visualization that had movie genres and then calculated the mean of something. So it was the mean production budget up till now. Can we do the same thing for revenue? We've created this extra column called revenue. Can we use it? And the answer to that is yes. We can actually let's take this and put it over here. This is what we're going to want to build. So let's copy and paste this. We need to chain a few transformations here. So transform calculate, that's fine. Revenue, we've calculated. Now we need to aggregate. So we have this extra column now, but we need to tell Altair that we would like an aggregation. So transform aggregate, and we're going to add, this should be mark. We're going to go to a bar chart here now. Transform aggregate. So what do we want to aggregate on? We want to aggregate on group by measure genre as before. And then we want to calculate this new column called mean revenue, which should have the mean of the revenue, this extra column that we've created. So we've created this column called revenue up here. And now we've created this extra column called mean revenue. And down here, what we want to plot is mean revenue on the y-axis. Oops, let's transform this. We wanted this to be on the x and this to be on the y. Okay, one more quick transformation. Sometimes we want to transform the data not just to create a new numerical column, we want to create something else. So let's say we have a number like production budget, and we want to encode it using a nominal variable, which is either expensive or cheap. Okay, so movies are either expensive or cheap. We want to know which movie genres have more expensive and more cheap movies. So how do we do that? So we can apply this. So we're going to use the same transform calculate, but we're going to create a new column instead of revenue, and that column is going to be called expensive or cheap. Okay, then we're going to use a JavaScript way of writing an if or else statement. So we're going to say datum dot production budget greater than, let's pick a number like this one. Okay, so if a movie costs more than $200 million, then we will consider it expensive. So the way JavaScript evaluates this is it says, if this is true, do something. So this is the if statement. So if true, spit out expensive. Else, that's the little colon, spit out cheap. Okay, so this will say, I'm going to run through every row, look at the production budget, decide whether it's greater than 200 million. If it is, I'm going to say it's expensive. Otherwise, I'm going to say it's cheap. So we don't need the transform aggregate anymore. And we're going to go back to our dot plot because we want to know different movies. So mark point. So we're going to put major genre on the x-axis, and on the y-axis, now we're going to go back and use our production budget. And then we're going to color these by whether they are expensive or cheap. So the transform calculate has created this additional column for us that is a nominal type. It is a word. It's either expensive or cheap. And now we want to color based on that additional column. So let's run this. And we have a nice visualization. And you can see that action and adventure movies have the bulk of these expensive movies, and the rest of the genres do not. You can also see the documentaries and concert performance are quite cheap relative to these and other ones. So there will be some situations where we have just too much data, like there are more rows than we need, and we somehow need to get to a subset of those. For that, one of the ways we're going to do that is transform filter. So transform filter will basically allow us to eliminate rows that match or don't match certain kinds of conditions. So let's say we have a question like this. What's the mean production budget for movies with more than 500 votes and a rating of greater than 5? So we want to basically find a subset of the movies that has this particular condition. So the way we're going to do that is we're going to make a chart using movies and use transform filter. Okay, and the way we're going to implement the filter is we're going to say we have two conditions. So one is that alt datum, so the row that we're looking at, the IMDb votes, that is the number of votes for that movie, should be greater than or equal to 500. And, that's the little ampersand, alt datum.imdb rating should be greater than 5. So every row that passes this filter will remain in the data set, and those that do not, they don't match one condition or the other, will be removed. So now we can do mark bar. So similar to all the other visualizations that we've done so far, just we've reduced the data set using this transform filter to look at the data that we actually cared about. So just going to copy and paste this. We're going to show just another example related to this, just as we did in the other example where we had alt datum. We can actually feed in a string that describes this kind of as a JavaScript function. So instead of alt, we'll get rid of that. And like that. So this is a string that is a program that will get decoded by JavaScript when Vega Lite decides to render this, and this will basically implement the same filter. So notice we just don't use Alt anymore, and we can just use data on IMDb votes. The parentheses you could have kept if you wanted. So filters are actually implemented through these like weird things called predicates. So there is a function that describes less than, greater than, equal to. So the same operation that we've done before, let's just build it like this. So we're going to say transform filter, and there is something called a greater than or equal to predicate. So it looks something like this. Altair field greater than or equal to predicate. That's the GT greater than or equal to predicate. We tell it what field we care about. So field, the greater than or equal to operation should be applied to the IMDb votes, and the greater than or equal to operation should be 500. Okay. Because we want two different filters to happen, we can't pass two of these field predicates simultaneously. We have to do another transform filter. And when we run this, it's basically going to apply this object, this filtering object first, greater than or equal to, and then this greater than for the IMDb ratings. And at the end, we're going to get the exact same visualization. So this is might strike you as a little bit of a pain. Like, why would you actually do this? It turns out that there are other useful predicates that they don't have a specific operation. Like, you can't make the greater than or equal to sign. Two of these include the field one of predicate and the field range predicate. So let me show you how these work. Let's say we only want movies that are either drama or comedy. So we can apply the one of predicate to do that. So let's make a new transform filter, and we will specify this predicate called field one of predicate. We want it to operate on the measure genre column. And then its argument is going to describe an array of things, that is the list of things that we would like to match against. So if major genre is one of either drama or comedy, pass that through. Otherwise, block it. And the way we would use the field range predicate is both kind of a less than, greater than operation simultaneously. But let's say we only want movies that have an IMDb rating between 5 and 7. So transform filter, and then we're going to do alt dot field range predicate. We want it to apply to IMDb rating with a range between 5 and 7. So if the IMDb rating is between 5 and 7, the row will pass. Otherwise, it will fail and be rejected. So the final data set will only include movies that are either dramas or comedies with an IMDb rating between 5 and 7. And let's just plot this. So mark bar. All right, we'll execute. And we have our visualization. So we filtered the data set we wanted, and now we have a new bar chart with only those movies you can see at the bottom that are between 5 and 7 on the IMDb scale. All right, one last thing. I'm going to copy this code. Oops, just the code. And you will probably never actually want to do this, but I just want to show you because you might see examples out in the wild. So because it's a little bit of a hassle to write transform filter multiple times, there is a way of feeding a object to transform filter and specifying the kind of Boolean logic that we want to operate on multiple field predicates. So we can do something like this. We can feed in a JSON object and specify that the logical operation that we want to apply is and we would like to take, so this will take a list of the things that we would like to and together. So we can end it like this, and the list, and the JSON object. So again, this is maybe a little bit easier to read, like this. You will probably never want to do this, but it is possible to take multiple filters and basically put them together by putting them in a list and then specifying how you want to treat those things. Do you want them to be an or? Do you want them to be an and? So you can run that and you'll get the same visualization. All right, we're in the home stretch. Just a couple more transformations that you might find valuable. The first is a sample transform. So sometimes you have too much data, but you don't want to filter anything specific. Like you just want to sample a subset of the data. So you can do that using transform sample. So again, alt chart, movies. Let's make a bar chart. We're going to encode, and we're going to do alt X, IMDb, rating, quantitative, and title, nominal, and then transform sample 10. So it doesn't actually matter. I could have run the transform sample before the encode and after. It's the same thing, but just put it here. We'll run this. We'll get one visualization. Now, every time we run this, we're going to get something totally different because it's sampling different data from our data set. So this is how we get sort of a subsample of the data. All right, last one, and this is perhaps a more useful one. Window transformations. Window transformations, there are a lot of different types of these things. In the examples that we've seen so far, we've largely looked at one row at a time. So we've looked at the data set and looked at each movie and made some decision or transformed it in a specific way. Even when we've aggregated, the end result is we don't actually care about other rows in the data set. There are situations where it is important to look at other rows. For example, if we are doing a running average, like we've sorted something by time and we want to calculate a running average. To calculate the running average, we need to look at multiple rows in order to do that. Same thing applies for calculating something like rank. So to know the rank of a movie in some list, we need to know where it sits relative to the other movies. So to do these kinds of operations, we have window transforms, and window transforms allow us to look at other rows. So we have to specify the sort order, but then we can look at things like leading, lagging indicators, aggregating or summing over the entire distribution, so looking at the past data and so on. So I'm going to show you a simplified kind of example using the window transform, or transform window, sorry. So we're going to basically calculate the rank for all the movies based on their IMDb score, and then I'm going to look at the top 10 movies. So you can see them. This is the end visualization. So The Godfather at the very top, going down to Toy Story, and you see a point reflecting their IMDb rank. So you can see that The Godfather and The Shawshank Redemption tied. Then there's Inception, The Godfather Part 2, and then a bunch of other movies that sort of are tied at number 5 in terms of the rank. So they have the same exact score. So how do we do this? We're going to create a chart, Altair chart, movies. I'm going to make it a little bit wider so you can see it a little bit better. So the width of the visualization is going to be 600. Then we're going to run this transform window operation. So transform window takes a few different arguments. The first argument, we need to specify how we want to sort the data. So we're going to sort the data by, so sort equals, we're going to use the Altair sort field. And it's going to do the IMDb rating. And because we want it to go from top to bottom, we're going to use descending order. So order equals descending. So this is how we order the data before we actually calculate anything on it. Next, we're going to say what column we want to create. So we're going to create this new column called IMDb rank. And then we need to specify what we want to do with the window. So basically we've sorted the thing. What do we want to do with that? There's a bunch of operations that we can use. We're just going to use this one called rank star, which basically looks at the data we're currently looking at, decides what rank it is relative to what it's already seen in that sorted list, and will spit out a number. So the rank will become a number that is held in the IMDb rank column. Okay. As I mentioned, we only wanted the top 10 movies, so transform filter. We have alt datum IMDb rank. So that's the column we just created. We want it less than 10. And then let's make a circle plot, code. So when we make this plot, we have the movies, the right movies and the right data, but they're no longer ordered in the way we showed before, because it's just in the order in which the data appears in the data set. So this sort order does not necessarily hold when we plot. It's a temporary sorting. And so if we want to maintain that sort order, like we want the top movie to be at the top and the worst of the 10 to be at the bottom, we need to add an additional sort operation when we define the Y encoding. So we're going to do it this way. So we're going to say sort alt encoding sort field. And the field that we care about is the IMDb rank, right? So the IMDb rank is going to tell us where to place things on the y-axis, and the order should be ascending in this case. So we want going from top to bottom, so like this. And now we get the visualization that we wanted. All right, so we're going to wrap up there. Hopefully you found this useful. There's a lot of combinations of transformations. So I know this was a lot to cover in one particular lab, but hopefully it gets you going on dealing with data that you find out in the wild and actually getting something reasonable to plot on the screen without, having to do lots of manual fixing. So hopefully you have been able to follow along with this. We will give you, of course, the completed version of this lab exercise, but it will pay off if you've tried it, because some of the homework questions will sort of, depend on an understanding of some of the transformations. And with that, thank you for listening.